Everybody, let's take a look at analyzing motion and finding distance. This is something usually considered a bit tricky or hard, so I'm going to show you a graphical way to think about this. Might be helpful to you. Okay, so here's our position function. S of t equals t squared minus 6t. I just made this up. For the sake of simplicity, only two terms. Okay, so the derivative is found by doing v of t, or you can write s prime of t, makes no difference, equals 2t minus 6, so just use the power rule. Then you take your velocity, which expression, which is 2t minus 6, and you set it equal to 0, right? So 2t minus 6 equals 0. You solve that. Here it's pretty easy because it's just t equals 6 divided by 2, which is then equal to positive 3. Done. So what does that number actually mean? So here it's helpful if you look at a graph very carefully of the velocity function to see what happens around t equals positive 3. That's very important here. Okay, so let's look over here at the graph. Let me just zoom over into this other graph reality. So this is v equals 0 right there. Okay, this straight line is the velocity function. And what do you see happening, right, around v equals 0 carefully? Well, on the left side of t equals positive 3, v is equal to 0 right there, right? Again, this is t equals positive 3 in terms of the horizontal axis, but it means that the velocity is 0 there. Notice on the left side of t equals positive 3, the velocity is a negative quantity. On the right side here, the velocity is a positive quantity. Okay? So that means you're switching from negative to positive. The only way to do that is you have to go through 0 right there. What does that mean about the shape of the position graph at t equals positive 3? Okay, so I'm going to come down to the position graph. Look at it carefully. On the left side of t equals positive 3, which is this arrow tip, you see that the position graph is going down. That means there's a negative slope. On the right side, as you can see, the position graph rather is going up. That means it has a positive slope. Okay? Now I'm going to zoom back out and look very carefully at the next stage in the process. Imagine we want to do this. Go back over here. Imagine our goal is to find the total distance traveled from t equals 0 to t equals positive 7. That's our goal. Okay, first of all, we don't have any graph called a distance graph. So we have to use the position function, which is the green graph. But how do you use the position function and then the velocity function? They are related, and you need to use both to answer this question. So the way to do this is you first, for example, graph the velocity function as I did. It's just a slanted line, and you see that t equals 3, its value there above my head is equal to 0. Okay. So that's like saying the following. Look at the green graph. That's the position graph. The way to do this then is as follows. Right above my head, this is t equals 0. The position there is also 0. It's like saying you're starting from the origin. And then at t equals positive 3, which is where the velocity is 0, you look down to the position graph, and you look at its y-coordinate there, whatever that is, that's about to negative 9, say. And then what you do is you form this quantity, f of 3 minus f of 0, and you take it in absolute value because we're calculating distance. And it tells you the distance traveled by your particle, for example, from t equals 0, right? So t equals 0 is right there, to t equals positive 3, which is right there, you see? So you form this quantity. It tells you the first distance traveled. But then we said we also want to do this from t equals 3 to t equals 7. Okay, so now we have to compute the other side of it. So look at the graph carefully. So this arrow represents f of 7 minus f of 3. Okay, let me just stress. Look below me. You see that the slanted line is the velocity function, isn't it? Notice that at t equals positive 3 all the way to t equals, what is that, 7 right there? Right, the velocity is this part, is this graph. That means it's always positive. It's like saying you're always traveling to the right, for example. Okay, so that means you would compute the distance traveled there by doing f of 7, which is where we decided we wanted to stop our motion, minus f of 3, which is not arbitrary. The fact that this is a 3 below me right there is important to understand, is where the velocity switches from negative to positive. So this 3 here is not an arbitrary number, right? It's a very specific number present because it's where the velocity switches from negative to positive in this particular example. Okay, so then you're going to do f of 7 minus f of 3, which is essentially like computing the length of this arrow right there. That's all, because f of 7 is just a y-coordinate right above my head. That's f of 7. Whatever that y-coordinate is, you can tell it's about 7 itself. F of 3 is just a y-coordinate. So that's about right there. You see the same level as where this arrow ends. That's about -9. So you do f of 7 minus f of 3, but you do it in absolute value because it's distance. And then to find the total distance traveled, you just add these quantities together like this, you see? You just do f of 3 minus f of 0, in absolute value, it's about 9. Okay, and then f of 7 minus f of 3, in absolute value, wherever that is. The numbers themselves are not the focus here. The focus is to understand how to use the velocity and position graphs together to answer this question. Alright, I hope this is helpful. If it is, please be sure to leave a like, subscribe, check out the other videos on this channel.